Dear learner, I welcome you all to the MOOC on Principle of Electrical Sciences. I am Dr. Sanjay Agarwal, Associate Professor in Electrical Engineering, School of Engineering and Technology, Indira Gandhi National Open University, New Delhi. Dear learner, in previous session we have discussed phasor diagram and parallel operation of synchronous generator. Then we discussed operating principle of synchronous motor, and after that we also discussed why synchronous motor is not self-starting. Then we discussed different starting method of synchronous motor and applications of synchronous motor. Dear learner, in the coming few sessions we are going to start new unit, that is electrical installation. In this particular session we would discuss service mains, single phase distribution system, house wiring circuit, methods of wiring and various circuit diagram like one lamp, one fan and one socket outlet controlled by individual switches, staircase wiring, and then we will also discuss how the bedroom lighting circuit is designed. So as you know, the term power system. So basically power system has three main components, that is called generating system, then transmission system, and third is distribution system. So as you know, generating system is where electrical power is generated, and this power can be generated from the thermal power plant, from the nuclear power plant, hydro power plant, solar power plant. Then this power is transmitted with help of the transmission line. So transmitting the electrical power from generating station to the distribution side, that is called transmission system. And after that, this high voltage is stepped down at distribution center with help of the step down transformer, and then with help of the distribution transformer again this voltage is stepped down, and then this power is transferred to the load center, or you can say this power is transferred to the consumer side. So this is all about the power system. Now we have to understand what is the electrical power distribution system. The main function of an electrical power distribution system is to provide power to individual consumer premises. The distribution of electrical power to different consumer is done with a much lower voltage level compared to the transmission of power over long distance. Distribution of electrical power is done through distribution network, and distribution network consists of following component. You can say first one is a distribution substation, then primary distribution feeder, then distribution transformer, and after that distributors comes, and then this electrical power is transferred from distributor to the consumer side with help of the service mains. Here you can see in this diagram that this S is denoting basically either generating station or substation. So this SM and SO is denoted as a feeder, and this MNO and MPO denotes the distributor. So here you can see this MN, or you can say this ON is a distributor, this MP is also distributor, and PO is also distributor. So this power can be transferred from distributor to the consumer with the help of the service mains. So here at the domestic application, or you can say in your household, you get the supply at of 230 voltage, or you can say 240 voltage. The power is transmitted from generating station or substation to the utility centers by means of transmission line, and from there power is distributed through distributor, or you can say distributing lines. The consumer are provided power supply by tapping connection from distributing lines. The consumer's premises is connected to the supplier distributing lines through use of cables and through overhead line in case of the distance of consumer's premises from nearest distribution line supports exceeds 45 meter. So now we have to understand what is a service mains. The connection of supply distribution line to the consumer meter is called service mains or service line connections. Now these service mains can be classified as overhead service line and underground service line. So under overhead service line, all aluminum conductor and ACSR, that is aluminum conductor steel reinforced or hard drawn copper of different size, are used according to the load demands. So you can say for copper conductor minimum size used is 10 SWG and it is used for the maximum load of 1 kilowatt. And then 8 SWG copper conductor, or you can say all aluminum conductor or all aluminum conductor steel reinforced, are used for the domestic or the commercial application for the maximum load of 2.5 kilowatt. Then you can understand that 6 SWG copper all aluminum conductor or ACSR, that is all aluminum conductor steel reinforced, are used for the maximum power load, that is at 12 kilowatt. Now we have to understand what is the underground service line. So for underground service connection, PVC cables, that is polyvinyl chloride cables of aluminum or copper are used. Low tension 3.5 core cable is used for the underground service connections. Now we have to understand what is single phase distribution system. So here you can see in this particular diagram, the vertical dotted line is dividing this whole figure into two parts. So this left hand side you can say this is a supplier property, and on the right hand side it is called basically consumer property. So here you can notice that at supplier properties there is a service poles, and this service mains and energy meter are there. So here you can notice that you can see there is a 3-phase connection RYB, and the top wire is basically of earthing, and last one wire which is a lower wire, that is basically neutral wire. So because we are discussing the single phase distribution line, that means you have to take only single phase supply. So here you can see that from the B phase wire is taken out, and from the neutral one wire is taken out, and third wire is taken from the earth wire, which is being connected to the energy meter. And then this energy meter is connected to the main switchboard, and this main switchboard is connected to the distribution board, and from this distribution board different circuits may be connected. So here you can see that 4 circuits, circuit 1, circuit 2, circuit 3 and circuit 4 are connected. For single phase supply, the service line has 3 wire, phase wire, neutral wire and earth wire, running from the supply pole to the consumer premises. In case of 3-phase supply, as required for giving supply to the workshop, cinemas, houses, hospitals, hotels, the service line has 5 wire, namely 3-phase wire, it is called RYB, and 4th wire is a neutral wire, and 5th wire is a earth wire, which is running from supply pole to the consumer premises. Now we have to understand the house wiring circuit. Electrical wiring is a process of connecting cables and wire to the energy consuming devices such as fuse, switches, sockets, lights, fans and other appliances to the main distribution board through safety and controlling devices for the continuous power supply. Here you can note down that as per Indian standard, maximum number of point of lights, fans and 5 ampere socket that can be connected to one circuit is only 10, and total load is 800 watt. Here you can see the house wiring circuit. So here you can see that there is a 3 wire, you can see there is a phase, neutral and earth, and this service mains are connected to the meter board. So meter board have basically this single phase energy meter, and here you can see also that phase and neutral are coming through this supply cutout and the neutral link, and then this meter board is connected to the main distribution board, and from the main distribution board there are different sub distribution board are connected. Here you can see that sub distribution board are 1, 2, 3 and 4. So here you can also see that from sub-distribution board 4 there are different circuits are connected, which you can see here like sub-circuit 1 and sub-circuit 2. So as the different circuits are connected from the sub-distribution board 4, so on the same way different circuits are connected from the sub-distribution board number 1, from the sub-distribution board 2 and sub-distribution board 3. In distribution board system, which is most commonly adopted for distribution of electrical energy in a building, the fuses of the various circuits are grouped together on a distribution board, sometimes simply known as fuse board. Connections necessary for connecting two or more than two circuits, each consisting of 10 or less number of lamps. The two copper strips known as bus bars fixed in a distribution board of hardwood or metal case are connected to the supply mains through a linked switch so that the installation can be switched off as a whole from the both poles of the supply if required. The number of circuit and sub-circuit is decided as per the number of points to be wired and load to be connected to the supply system. For determination of load and installation, the following rating may be assumed unless the values are known or specified. So here you can say that we are taking different type of load. You can say fluorescent lamp, incandescent lamp, fans, socket, power socket outlet, exhaust fan, air conditioner. So for the fluorescent lamp, generally you can assume that fluorescent lamp generally is of 50 watt, and this lamps, fans and socket outlet may be of 60 watt, and power socket outlet is generally taken of 1 kilowatt, or you can say 1000 watt, and exhaust fan and air conditioning is specified as per the capacity of the exhaust fan and air conditioner. Suppose we are using the air conditioner of 1.5 ton AC. So 1.5 ton AC generally it is equivalent to 2 kilowatt. So if you want to see how much power is being consumed by that air conditioner, so just you can read on that one plate is on the AC, and here from there you can mention how much power will be consumed by that air conditioner and exhaust fan. Now we are going to discuss the methods of the wiring. Wiring, which is a process of connecting various accessories for distribution of electrical energy from supplier's meter board to home appliances such as lamp, fans and other domestic appliances, is known as electrical wiring, which can be done using two methods, which are loop-in system and second one is joint box or T system. So first we are going to discuss loop-in system. Loop-in system method of wiring is universally used in the wiring. Lamps and other appliances are connected in parallel so that each of the appliances can be controlled individually. When connection is required at light or switch, the feed conductor is looped by bringing it directly to the terminal and then carrying it forward again to the next point to be fed. The switch and light feeds are carried round in the circuit in a series of loops from one point to another until the last on the circuit is reached. The phase or line conductor are looped either in switchboard or box, and neutrals are looped either in switchboard or from light or fan. Line or phase should be never be looped from the light or fan. So here you can see in the diagram that there is a two wire phase and neutral. So here you can notice that the wire which is going through the switch, that wire is basically of phase wire, and neutral is reaching directly to the lamp or the fan. So from the looping is done from the one switch to the another switch. Here you can see in the diagram also. Now we have to understand what are the advantages of loop-in system of wiring. So first advantage of loop-in system of wiring is no joint boxes are required, and second advantage is no joint is connected below the floors or in roof spaces. And third advantage is it is easy to locate the fault. Now, because loop-in system has some advantage, so at the same time it will have some disadvantages too. So disadvantages of loop-in system of wiring are as follows. First one is length of wire or cable required is more. So if length of wire or cable required is more, that means if length is more, so of course the resistance of that wire will be more. If resistance of the wire is more, so second disadvantage of this system is what? Voltage drop will also be more, because as length is increasing, so resistance of the wire is also increasing. And third disadvantage is copper losses is more in case of loop-in system of the wiring. Reason is what? Because length of wire or cable is more. So as length is increasing, so of course resistance of the wire is also increasing. So if resistance of wire is increasing, so that copper loss can be said as I square R. So as resistance is increasing, that means you can say this copper losses is also very high in case of loop-in system of wiring. Then next disadvantage of loop-in system wiring is what? It is difficult to loop in switches and lamp. So this is all about the advantage and disadvantage of loop-in system of wiring. Now we are going to discuss joint box or T system of wiring. In this method of wiring, connections to the appliances are made through joints. These joints are made in joint boxes by means of suitable connectors or joint cutouts. This method of wiring doesn't consume too much cable size. You might think because this method of wiring doesn't require too much cable, it is therefore cheaper. It is of course, but the money you save from buying cables will be used in buying joint boxes, so equation is balanced. This method is suitable for the temporary installation and it is cheap. So here how this joint box or T system of wiring is done, you can see in the this diagram. Now we are going to discuss the advantages of this joint box wiring system. So first advantage is what? This method of wiring doesn't consume too much cable size. Second advantage is length of the wire or cable required is less. Third advantage is because size of the or you can say length of the wire or cable is less, so voltage drop is of course very less. And on the same way, because length is less, that means resistance is less. If resistance is less, that means whatever the losses which is occurring due to the resistance of the wire, that is a copper losses, is also less in this wiring. Now we are going to discuss the disadvantage of this wiring. So first disadvantage is poor appearance. Second disadvantage is frequent occurrence of the fault. And third disadvantage is difficult in locating faults. This system is not suitable for regular domestic wiring. However, we may use it for temporary wiring such as for the marriage pandal or fair pandal. And next disadvantage of this wiring is it requires plugs and socket at different sizes. Now we are going to discuss various circuit diagram. So under various circuit diagram, first that we are going to discuss, that is one lamp controlled from one point. That means you have to switch on or switch off one lamp only with the help of the switch. So here you can see that one lamp is taken. There is a two terminal in the lamp, and here you can see there is a switch. Switch has also a two terminal. So the phase terminal is connected to the switch. So here you can see as switch is connected, so this circuit will be completed from phase to the neutral. That means the supply is going from main distribution board through the phase, and this phase goes to the switch, and then the supply goes to the lamp, and the second terminal of lamp is connected to the neutral. So as you switch on, the supply will flow through the lamp and lamp will glow. As you switch off the switch, this lamp will not glow. So this is how you can control one lamp by one switch. Second circuit diagram that we are going to discuss, that is a socket outlet controlled by one roll switch. Relative position of the socket in a 3-pin socket when viewed from the front arc as shown in figure A. Here you can see there is a 3 terminal. So the larger socket marked as E and which is used for the earthing connection. The left hand socket for the neutral wire and right hand socket for the live wire. Here you can notice that topmost terminal, that is earth, the dia of that terminal is more in comparison to the rest of the 2 terminals like neutral and line. Reason is what? Reason is only because as dia of that terminal is more, that means resistance is less, because R is inversely proportional to the area and area is proportional to the diameter. So as dia is more, that means area is more. If area is more, that means resistance is less. So in case of any short circuit or fault, so what will happen? Current will start flow through the earth, because current always flows through the least resistance path. That's why the pin of the earth have larger diameter in comparison to the neutral and line. Now here you can see in the figure B that there is a one socket which have 3 terminal, earth, phase and neutral, and there is another one switch has been shown on the left hand side. Here you can see that phase wire is going through the switch and the terminal of the socket of earth is connected to the earth wire and neutral is connected to the neutral wire of that particular socket. So as supply, or you can say line, is coming through the phase and this supply is going through the switch. So as you switch on and switch off, so then that means you can control the power supply in that particular socket. Now we are going to discuss 2 lamps controlled by individual switches. The connections of 2 lamps controlled by individual switches in looping in system as shown in the figure. Here you can see that there are 2 lamps, L1 and L2 has been shown, and there are 2 switches, that is switch S1 and S2. Here you can see. So that means you have to control these 2 lamps L1 and L2 individually. So what you will do? Just you connect one terminal of the switch from the phase, and then looping can be done from switching S1 to the switching S2. That means this phase wire is going firstly to the switch S1 and then this phase wire is going from switch S1 to S1, and this neutral can be directly connected to the lamp 1 and lamp L2. So by controlling switch S1 and S2 you can complete the circuit. So as circuit will complete through switch and which connect phase and neutral through the lamp, that means current will start to flow, that means lamp may be switch on. Similarly, both lamps can be controlled by individual switch S1 and S2. So this is how you can design 2 lamps controlled by individual switches. Next we are going to discuss 1 lamp, 1 fan and 1 socket outlet controlled by individual switches. The connection diagram of 1 lamp, 1 fan and 1 socket outlet controlled by individual switches are shown in the figure. So here you can see that here we are controlling 1 fan, lamp, and then we are also having a 1 socket. So because there is a 3 devices, you can say, one is a fan, another is lamp, and third one is a socket in which you can use any appliances. You can use your mixer, you can use your iron, and here you can also notice that through connecting to connect the fan, regulator has also been used here. So what you have to keep in your mind, that all the connection which is going through the switches, that wire is a phase wire, and neutral is directly connected to this fan, lamp and this socket, and earthing is also connected to the this socket, where you can see that is a which have a larger diameter, that earthing is connected here. Now we are going to discuss staircase wiring circuit. So in figure A you can see that you have to control one bulb which is connected in the stair. So what is the meaning of this? That means suppose you want to go to the on the any floor, on the top floor, that means you want to switch on the you want to switch on this light. So this switch can be done from the this at the lowest staircase, and it can also be controlled at the by the another switch which at on the top on the another floor. So you can see that switch A as the ground floor and switch B on the upper floor. So here you can see as in figure 1 that this bulb, or you can say lamp, is connected from the distribution board, and there is a two switches are used. Here you can see that switch A and switch B. In figure 1 you can notice this is lamp on position, where here you can see that phase is connected through switch A and it is connected to the switch B, and it is going through the lamp, and then it is going to the neutral. So that means this circuit is complete. Now suppose you want to switch off the light by the switch B. So here you can see in the figure 2, that means when you operate the switch B, that means this circuit will be disconnected and this light will be off. Now suppose you are on the ground floor and again you want to switch on the fan. So just you switch on the switch A, and here you can see in the figure 3 how this bulb can be switched on by switch A and switch B. Similarly, figure 4 shows the switched off by the switch B. So this is how you can connect the staircase wiring circuit. Now we are going to discuss the bedroom lighting circuit. So here you can see in the diagram that there is two lamps are there, L1 and L2, and here you can see that two switches are there. One is a one-way switch and another is a two-way tumbler switch are used. And here you can also see two-way pendant switch are also connected. So in bedroom lighting circuit, bedroom is usually provided with two lamps, one lamp near the dressing table controlled by one-way switch, and another lamp near the bedroom controlled by two-way switches. One of these two-way switches should be tumbler switch and another should be pendant type suspended from three plate ceiling rows. Now we are going to discuss different type of electrical wiring system. So there are different type of electrical wiring systems are there. First one is cleat wiring, second is wooden casing and capping wiring, third one is CTS or TRS or PVC sheath wiring, then lead sheath or metal sheath wiring, and last one is conduit wiring. So here just we are going to discuss only the conduit wiring. So in conduit wiring there are two additional type of conduit wiring are used according to pipe installation. First one is called surface conduit wiring and second is called concealed conduit wiring. Now we are going to discuss surface conduit wiring. If conduit installed on roof or wall, it is known as surface conduit wiring. In this wiring method, they make holes on surface of wall on equal distance and conduit is installed with help of Raval plugs. Now we are going to discuss concealed conduit wiring. If the conduit is hidden inside the wall slots with help of plastering, it is called concealed conduit wiring. In other words, the electrical wiring system inside wall, roof or floor with help of plastic or metallic piping is called concealed conduit wiring. Obviously, it is the most popular, beautiful, stronger and common electrical wiring system nowadays. Now we are going to discuss advantages of this. First advantage is it provides protection against mechanical damage. Second advantage is it provides complete protection against fire due to short circuit. Third advantage is the whole system is waterproof. Fourth advantage is replacement and alteration of defective wiring is easy. Next advantage is its life is long if the work is properly executed, and it is shock proof also if earthing and bonding is properly done. Next advantage of this wiring is it is very complicated to manage additional connection in the future. Now we are going to disadvantage. It is expensive wiring system due to the PVC and metallic pipe, additional earthing for metallic pipes, T and elbows. It is very hard to find the defect in the wiring. Next disadvantage is installation is not as easy as and simple. Next disadvantage of this wiring is risk of electrical shock, and it is very complicated to manage additional connection in the future. So dear learner, in today's session we have discussed service mains, single phase distribution system, house wiring circuits, methods of wiring, various circuit diagram like one lamp, one fan and one socket, outlet controlled by individual switches. Then we discussed staircase wiring circuit and bedroom lighting circuit. Dear learner, hope you are able to learn all the topics. In the next section we would discuss types of the wire and cables and components of the LT switchgear. We will also discuss different fuses and earth leakage circuit breaker. Thank you very much.